Okay, Assalamualaikum warahmatullahi wabarakatuh. For this paper, our title is gonna be it's a comparative analysis of user interface and interactivity design guideline aspects for algorithm visualization mobile tool. So this is Ahmad Afandi Supri, and the second author of this paper is Professor Dr. Nur Syuhada Siratuddin from SMMTC UUM. So let we talk about the content of this paper. It consists of five. The first is gonna be introductions. The second is literature review. The third is about comparative analysis one. It's about the results of it, which is the recommendation for UI designs aspects. The fourth is a comparative analysis two, and the results of it, a recommendation for interactivity aspects. The fifth is about conclusions. So now let's talk about the introductions. As you can see from the title, it's about algorithm visualization. So we have to know first what the definition of algorithm visualizations. The definition is that the dynamic is a system which has dynamic visual representation of the behavior of an algorithm or data structure, which the goal is to help students learn algorithms. So as you can see from the picture, there are a bunch of systems that have been created. These are our AV systems, algorithm visualization that can demonstrate students step-by-step processes of the behavior of an algorithm so that students can see a step-by-step process of it, such as bubble sorting algorithm, insertion sorting algorithms, selection sorting algorithm, and many others, data structure, etc., etc. So for today's research instead, we are not focusing on the tool, but we are focusing higher than that, the higher hierarchy of it, which is the design's guidelines. However, in the existing studies, the comprehensive design guidelines for algorithm visualizations tools in terms of designing user interface, UI, and interactivity factors, they are still very limited on or discussed separately in the previous studies. Even though there are many evidence in previous empirical studies showed that various interactivity strategy and UI design aspects are two imperative aspects to make an effective AV tool for learners. Yeah, so it's not only one or two interactivity, it has to be a various interactivity strategy and UI design aspects in the mother of design guidelines of AV. So these two imperative aspects. Within this context, this paper proposes the summary recommendation of these two aspects based comparative analysis on existing studies in order to form AV on mobile platforms AVOM design guidelines that serve as a systematic approach which includes the fundamental guidelines for designers, developer, and lecturers to produce AVOM. So this is a part of our studies before we are actually the last goal of this research is actually to make the design guidelines. However, in this paper, we talk about the first stage of it, which is the results of comparative analysis, which are actually a part of the initial stage before we form it into the design guidelines. So this is like the first born baby of the comparative analysis, which is the recommendation from these two aspects. So additionally, the existing AV design guidelines previously also lack of comprehensive practical recommendation of UI design and interactivity for AV on mobile platforms. Specifically, most of UI design aspect in the previous AV studies are prepared for desktop and websites, whereby mobile platform has which has different constraints such as small screen and features such as touch screen. This is still a lack of it. Moreover, now we are talking about in terms of interactivity factor, the existing AV design guideline on mobile platform employed. So there are actually few of AV design guideline on mobile platform in the existing study. However, they only employed the lowest level of interactivity, which is viewing level only in their AV guideline to demonstrate sorting algorithm as their case study. Basically, they just use step through navigation method only. The inclusion of interactive functions such as pause, stop, next, and backward buttons are utilized to demonstrate step-by-step process of algorithms. So basically, they only watch the things of interactivity they only have is only can press the button next to see the next behavior of the next line of codes in algorithm. Of course, it is indeed that the app show the animation for each line of codes, but this way only is in contrast with the previous aforementioned deliberation that I talked before that suggests a variety of interactivity must be included in the AV system, otherwise the impact of learning will be not significant. Specifically, this AV system can lead students to have a problem in terms of low engagement with AV system itself, and thus will affect on its effectiveness. So as you can see the relationship, if it is low engagement, it will affect into the low uh, low interactivity will lead to the low engagement, and it will lead to the low effectiveness or accomplishments basically. Now we are talking about the literature review. So why we bothered for mobile platform for this research? So before we talk about, now we are talking about the justification of it. Based on the Huang and Wu 2014, who reviewed 7 well-known social science citation index SSCI of publication journals regarding the influence of mobile application technology in enhancing learning, concludes that mobile learning is a promising in enhancing learning accomplishments, interests, and motivations. According to their survey that conducting 5 years of the paper, it is discovered that tablet, PC, and smartphone are gradually becoming the most used as a mobile learning device adopted application. So as you can see from the pictures, compared to with the other devices such as tablet, PC, notebook, smartphone, which is the red lines, has the biggest promising things that people like to learn from because it's so ubiquitous. Everybody use the mobile phone in everyday life until now. Moreover, in the current study, which is more latest one, as far as learning advancement are concerned, some studies have confirmed through quantitative analysis with pre and post tests, proof mobile learning yields significant learning improvement. Okay, now we are talking about the summary of it. The first summary, based on the result of comparative analysis 1, the recommendation of UI design aspects. So in order to get this one, we have extracting the recommendation. So this is the result of it. We compared 12 previous studies, and these studies basically consist from the study from UI design based on the mobile design guidelines, and we also collected some of previous AV design guidelines. We also see from UI design guideline and usability principle of designing in a mobile app, and many other section of the studies which are related one another. So this is the result. So first recommendation, I'm so sorry. First of all, we have to talk. There are 4 categories. The first is about content, and it consists of 4 recommendations. So let me read for you. So avoid much content in a small screen because it's the smartphone is very small. So we have to, one way or another, we have to make it as simple as possible. One of which using interesting event in pseudocode. So interesting event in pseudocode itself, it means we need to what do we call it, do not put a lot of algorithms, just make it as simple as possible. So, such as swapping algorithms, instead of we put 3 lines of swapping algorithms, we just summarize that this is actually done in a swapping algorithm. Just make it in 1 line, so do not elaborate a lot. So just summarize as good as possible, something like that, because it's a small screen. So the second content of recommendation is avoid scrolling of content. So we have to avoid the scrolling when you are using the smartphone, because it's not going to be nice for our eyes, because it will divert our attentions based on the study. The third is about give a cueing to emphasize essential information. So in here, there is a note, for instance, can use highlighted line of pseudocode for each step connecting the students with a corresponding graphical visualization. So for instance, there are 5 lines of codes. So we just need to highlight one of them and correspond with the animation presented beside. So it's going to be connected one another. So it's going to be giving the highlight or queuing. Yeah. The third is using the multiple view segmentations. So if you have a lot of algorithms there, just put them in menu or tab or something like that. The fourth, now the second category, navigation design. It has to be have a good design of hierarchical navigation system. It has to be clear what to press and what to do, and it has to be explained the focal point. So we have to show it the hierarchy, we have to show it the path where the eyes have to be landed on. So we have to check, we have to put together so that we can see the sequence from the app itself, from above to the button, from up to the button. Yeah. So the in terms of color, we have to use the appropriate color. No need to many color. We have to make it as simple as possible. If it is too much color, it's also going to be overwhelming. In terms of layout design, make a layout clear, simple, and obvious. And last but not least is make the related element close each another. Yeah. So as I told you before, pseudocode and animation, they are related each other. Don't make a lot of space or gap, just make it closer so that it's going to be obvious that they actually interrelated. So this is the comparative analysis number 2, and the result of it is a recommendation for interactivity aspects. So this is the recommendation which were classified from the comparative analysis. So this table is actually the recommendation from the comparative analysis that we have compared 11 previous study, and they are actually from the study of the previous AV design guideline, previous AV studies, previous mobile design guidelines, and many others. Yeah. So the comparisons is based on their similarity and engagement taxonomy theory. So as you can see, there are 6 category. So the first category consists of 3 recommendation. So in here, displaying step-by-step execution of algorithm visualization using control buttons. So this is a must things that all AV system has to have, showing the step-by-step execution. So they have to be able to press next button in order to see the next steps for the behavior of the algorithm. The second is about provide rewinding button. So not only you can play and watch forward, but also you are able to backward. So because of the students, sometimes they just blur or just misdirection or just forgot things or something, so they can recheck about the the last step that they just missed. The third is about show dynamic explanation during the visualization. It means not only we are showing the algorithm itself in a form of a pseudocode, but also we show a bit of textual explanation about a certain line. Okay, now the next recommendation is about provide relevant questions to be answered by students. So sometimes during you are watching the visualization or animations, we have to make such a pop-up feature so that the students going to be asked, such as the answer like, what is going to be the next animation, and we just provide a multiple choice underneath so that the students can actually forecast or can guess what is the next animation, so that like when you are as a lecturer, you are teaching in front sometimes. So the students is blah 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 going to the something like this. So give them like another engagement or variety of interactivity, which is respond. We need ask them to respond. So in the morning after you wake up, you have to A, brush your teeth, 2, tidy up your bed, 3, go to bed again, something like that. Yeah. Now the next category is about changing. So this is another interactivity strategy of or variety of it. Provide modifying input data for algorithm and also can generate random values. So in here they are able to change the number. For instance, in the system there are a certain number to be sort for. Now we are talking about bubble sortings. So there are 5 default numbers, for instance, in the system: 1, 2, 3, sorry, let's make it random. 1, 3, 7, 2, 10, something like this. But now using the changing, the students are able to change all of the number with their desired numbers. So it's up to them, like maybe they change into 100, 2000, 75, 8, 10, so up to them. So they are able to change this, so they can see more visualization experience, they can see more behavior. If we put this number, how the bubble sorting is going to be sorting this number. If we put this number, how the, so we can learn by seeing it with more example, more experience of learning, more generated values. So, and also in here, not only changing based on our desired number, but also can generate random values. So the thing is, we can provide a button, so when we press that button, it's gonna generate a random numbers to be sorted by the system, so something like that. So the next category is about constructing. So the result is should be AV should provide constructing activity. So we are not only can see the bubble sorting how they works, but also we ourselves can actually construct or do the constructing activity itself. So we are the one who do the bubble sortings. For instance, we are given a certain 7 numbers or 8 numbers to be sorted. So instead of system who do the sorting, we are the one who do the sorting. We are the one who construct the sorting. So we put this here, we swap this here, we swap this here, and then it's going to be related with the next recommendation, which is the system should be able to give feedback during constructing activity. So during the swapping or sorting or whatever we are doing, the system will give a feedback. If it is wrong, we will give a clue. If it is wrong again, we will give a warning. If it is correct, it will give the complement or something. Yeah. Now the next category is about control settings. Provide environment settings. So in here, maybe for instance, not only we are only showing the numbers for the visualization for the array that to be sorted by the system, maybe we can represent numbers with something else, like a bar graph or bar chart. Like 10, it's going to be like this, 20 going to be like this, 100 going to be higher bar. So we present with different types of visualization. So this is, we provide environment setting. Maybe we also can change the background if you don't like this background, so it's going to be more interesting, more appealing, because it's adaptive to the user's need or desired. Last but not least, about error handling. It's prevent and handle the error. So in here, we, for instance, in the changing, while they are able to change the input number to be sort, for instance, in bubble sorting, we prevent it and handle the errors. The thing is, there are a bunch of, not a bunch, sorry, there is a input text, if you know. So they can put the number with a space. So instead of number, for instance, they put alphabet. In here, we prevent that by disabling alphabet buttons. So they are not able to press the alphabet, because in here we only are able to sort the number instead of alphabet. So this is one of ways to prevent, or if you cannot prevent, handle the error. So when you press uh, what we call negative, you insert the alphabet into the system will tell you, please only insert the number. So this is one of ways to error handlings. Yeah. Okay. So the conclusion is that this paper talks about a part of our study, which is the initial stage before we creating the real design guidelines, which going to be captured in the next paper. So this paper only talking about the summary recommendation of both aspects, namely UI design and interactivity, and through the comparative analysis approach. The identified recommendations were grounded and constructed based more on relevant theories and empirical studies into comprehensive guidelines. At the end of the day, in the future study, based on this comparative analysis finding, the guideline will be then constructed more in a form of table in which each of guideline consists of do and don't recommendation, complete with explanation, implementation, and illustration. Yeah, so based on the recommendation, for instance, this recommendation 1, it will be taken and it will be given more explanation. It's going to be more detail with the illustration and implementation. Yeah, last but not least, the conceptual model also will be provided in the next study as another form of the proposed guidelines. So that's all for this presentation. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh.